For this next part, we're going to switch back and forth between logarithmic form and exponential form. This is really helpful for those of you that still struggle with logarithms because our brain has worked with exponentials longer. So sometimes if we see a logarithm and we're like, I have no idea what that means, switch it into exponential form and it will make more sense. So let's look at this first one. You have your examples right here. I'm going to summarize this for you. This A is in exponential form. There's my logarithmic form. There's 2 steps to switch back and forth. The first step is the base on your exponential becomes the base of your logarithm. That stays the same. The second step is that your input on your exponential becomes the output on your log, and your output on your exponential becomes the input of your log. So log base 3 of 81 equals 4. I want you to pause the video, try to change this next one into logarithmic form by changing these, or filling in those 3 spots. Okay. So we've got log base e of 1 equals 0. And remember, log base e can be shortened to ln. So also ln of 1 equals 0. Last one, this is log of 0.1. And remember, when no base is written, assume that it's a 10. And now you're going backwards. So you're going to change this one into exponential. But it's still the same 2 steps. The base stays the same. The input and output flip places. So pause the video and try this one. Okay, should have gotten 10 to the negative 1 equals 0.1. Base stayed the same, input and output flip places. Now let's use those to answer some of these. Since e to the 0 equals 1, then ln of 1 equals, well, we already filled that one in, 0. Next, we have e to the 1 equals e. Now for this one, a little trick that we have right here, I'm going to change this back into that. When your base and your input match, they basically cancel out and you get 1. So because the natural exponential function and the natural logarithmic function are inverses, they kind of cancel each other out, and we're just left with what the number that's left, or the n. Okay, last example. We want to use this inverse idea to simplify these. Well, ln and e are inverses, they cancel out, we're left with root 2. E and ln are inverses, they cancel out, we're left with 3x. This one, I'm going to rewrite that log base 10 of 2. So the 10 and the log base 10 cancel out, we're left with 2. So as long as that base and the input is the same, they cancel out, left with x squared. So that is everything with this changing back and forth and using those inverses. In the next video, we'll talk about properties of logarithms.